You're watching the Weiss channel. That. Today we're going to talk about rational and irrational numbers. I'm going to start over here and talk about these numbers right here. These numbers are called perfect squares, right? Because square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, square root of 36 is 6, square root of 49 is 7, square root of 64 is 8, square root of 81 is 9, square root of 100 is 10, right? Square root of 36, that's 6, for example, because 6 times 6 is 36. In all of these numbers, a number times itself makes the number. Okay, those are called perfect squares. 6 is the same as 6 over 1, right? If you tried putting 3 divided by 4, 3/4 on your calculator, you would get 0.75. Okay, that's called rational. It's a number over another number, one number over another. That's rational. But however, if you entered the square root of 37 on your calculator, you would get 6.0827625302982 and goes on forever and ever, and it does not repeat. That's called irrational. So if it's a perfect square, it's going to be what's called rational because I can make that into one number over another. But any number that's not a perfect square and it's in a square root, that's going to be irrational because it's the square root of a non-perfect square. Okay? So here's what the Delta Math assignment looks like today. For example, here's a problem that says, determine if the following is rational or irrational. Square root of 9. Well, the number square root of 9 is, and you get this drop-down menu. And your answer is going to be rational or irrational. Here, the answer is rational because square root of 9, that's a perfect square, right? You get this second drop-down menu. The choices are, it is a decimal that repeats. Well, that's not the case here. It is the square root of a non-perfect square. No. It is a decimal that terminates. No. It is a decimal that does not repeat or terminate. No. It is the square root of a perfect square. That is what this one is. Okay, the square root of a perfect square, which makes it rational. If you ask square root 39, that one's going to be irrational because it's the square root of a non-perfect square, right? 0.68, would you agree that's the same as 68 over 100? If you did 68 divided by 100 on your calculator, you get 0.68. That's rational. It's one number over another. It's a decimal that terminates. Right? 0.68, that terminates, right? What about 0.111111111? If you did 1 divided by 9 on your calculator, this is what you would get. If you get a repeating decimal, a decimal that repeats, that is called rational because it repeats. It's a decimal that repeats. When you have a repeating decimal, it's rational. Looking at this one, you have 0.383, 883, 8883, 88883, 888883, and so on. This is irrational because it's a decimal that does not repeat. Okay? There's obviously some kind of pattern here, but don't let that trick you. It's not repeating. It's irrational. 0.762050558546. This is a non-repeating decimal. It's irrational. It does not repeat. Once again, square root of 36, that's rational because it's the square root of a perfect square. But square root of 35, that's irrational. It's the square root of a non-perfect square. Any number that's not a perfect square, it's going to be irrational. It's going to be some decimal that you can't turn into one number over another. 0.395. This is 395 over 999. That is rational. It is a decimal that repeats. Okay? You've been watching the Weiss channel.